Okay, good morning and welcome to today's panel discussion on the reduced print defect rate. The printer has long been cast as the bogeyman on the production line, the source of the majority of defects. Modern printing systems are going beyond the physical handling of solder paste materials to provide real-time monitoring and improved performance. This panel will discuss recent developments along these lines. I'm delighted to be joined by a really strong panel today. We have Torsten Wegelin from ASUS to my right. Welcome, Torsten.
Good morning. Welcome to you.
Yeah. Then we have Harold Groom from Kurz Ersa.
Yeah, thank you. Good morning.
Hello, Harold. And then, of course, we have Rick Goldsmith from ASM Assembly Systems.
Good morning, Trevor. Good morning, all.
Okay, great. So let's get moving, get our very first question out there, and that is, what are the advantages of automating the stencil changeover? And that's an obvious one. I'm going to start with you, Torsten.
Thank you, Trevor. The question for automated changeover for stencils is actually easy to answer, because for all changeover tasks on a machine actually today, we would need an operator, and who needs to do this actually at the point of time the order change needs to take place. If you do have an automation system for that, then he can prepare the printing system. Everything is set up, everything is ready, and when the order change should be done, the machine could do it automatically without any, action of an operator by that time. So he can continue on other places, and in that case we are faster. The machine is doing this always with the same repeating quality and with everything. So we take load off the operator, and we can increase the performance of the complete line.
Yeah, I mean, it really is the last stage in automating the line to become almost lights out. Would you agree, Harold? Have you got any views on automatic changeover? Is that something that's on your roadmap for the future, or?
It will be for the future. We already made some experience with these automatic changeovers, and we had very few requests from the customers. But I think in the future that will change due to the drive that less and less people are on the line. It's more automated, and then it for sure makes sense to have a very repeatable and scheduled process in there that gives us the possibility to prepare the stencil when it's ready, washed for the line, put it in a magazine and have it there when the production has to be changed for the next product.
Right, okay. Rick, do you have anything on that particular topic?
Again, agreeing with both Torsten and Harold, some customers are very keen at the moment, as much automation as possible, but they're keen on talking about it. The implementation and the levels are slightly different. But also I feel the return of investment has to be calculated on the printer as well. Yes, next year we will certainly have automated stencil exchange, but it's coming in stages. So as Torsten said, decoupling the operator so the operator can put the stencil there and go away. That will work for some customers. In the future, will we see AIVs with that stencil magazine roving around and getting a just in time and changing over, taking the dirty one back into the clean station? It's just looking at that return of investment. Right. And I feel there's a variance of customers and certainly a variance of opinions.
Right. So the consensus, it sounds like, is that yes, it's on the roadmap. It's something that's coming in the future. So is single stencil changeover the optimum, or there are systems out there that do multiple stencil changeover? Is that overkill?
In my opinion, it's an overkill. We do have multiple stencil exchange systems, what we use for different approaches on a 3D print, for instance. But what we do, we have a scheduling, and we know actually what's coming next. And this material needs to be on the line at the right point of time. So you don't need to schedule like the next 10 days for production on a line. So you can keep those for cleaning, for preparation, or you can run the same product on another line. And in that case, you would need less stencils, because if you would have a stencil magazine of 10 pieces at 10 lines, that's good business for the stencil manufacturers, but not for our customers in the end.
Yeah, it's interesting. Also, it depends if you're in a high mixed environment, maybe it's more.
You need the right software system to manage this, that you have also the right material at the right point. And that's something later on for the AIVs, but also for the guy who is moving the stuff around the site.
Yeah.
Just for me, again, it goes back to that return on investment.
Yeah.
If you really are changing over once an hour, does it make much sense to have a 10-system magazine there for you, or the operator going through?
Okay. So I know at least a couple of you are using paste and cassette or syringe-based systems. Is there any data to correlate an improvement in reliability or not between cassette-based paste systems or syringe-based paste systems versus an operator who's applying paste by hand?
So I think Trevor, the advantage with the cassette system and enclosed head is that you really are taking care of that paste, and years ago in different factory environments that was absolutely key, and we talked about having that constant roll delivering the solder paste, giving you a constant process. But I certainly feel over the years that customers are taking more care of their factory environment. If they can't take care of the factory environment, they take care of the environment within the printer in terms of temperature and humidity control, and also looking at that paste roll and understanding that adding little and often, and with paste roll height monitors now being far more accurate, and the ability to then look at difference in changes of millimeters and then adding solder paste, I feel that perhaps some of the benefits that the enclosed head system had years ago have now eroded in factory sites.
I think there's also an element of the management of materials within the factory spaces has improved with these automatic component counter systems and storage systems and everything else. The inventory control is a lot tighter than it used to be. Do either of you have a view on this?
I absolutely agree. So it's very important to have the right amount of solder paste in front of the squeegee, because that's really what's giving you the printing accuracy. And so the environmental effect on the solder paste, whether it's in a jar or in a syringe or in a cartridge, it's not so critical anymore. 20 years ago, that was absolutely different. And at that time, the enclosed printing systems were really, in my eyes, the right choice. But nowadays the solder pastes are a lot better, and now we are talking more about preparing the solder paste before we put it on the stencil, so mixing up. That's very critical for a good start of the printing process, but also we got to make sure that we have the right amount there, and that's easily done with automatic dispensers that we have inside of the printers, and paste height control that we measure, in our case, directly in front of the squeegee, why the squeegee is traveling. And so we really get very accurate data there that's helping us a lot to keep a constant printing quality.
Okay.
So actually every dispensing system has a clear advantage against a manual adding of paste to the stencil, because the operator is not repeating with the same volume, with the same quality. And it's essential for the future that we also have, depending on the product, different product type, the amount of the paste roll in front of the squeegee regulated. So you need a little bit more paste if you have a pin and paste product, or you just need less paste for this product, etc. And that actually is the task we need to do with our dispense systems. That's why we have introduced the electrical dispense systems to control also these volume we put on the stencil precisely. No?
Right.
I just think also from the paste traceability point of view, customers were always, a lot of customers monitoring the traceability, and the verification of materials was pretty much local. But we're now seeing much more of a trend for remote verification, and that tracing of the material arriving at the factory to when it came to the fridge, to out of the fridge, to even to the mixing, so it's in optimum condition by the time it's being used in the printer.
I mean, that's a good point. I mean, and I mentioned this earlier, is that the mixing is important. And you don't get the mixing necessarily happening in the syringe or the cassette, but you do get it with the guy who's putting it on by hand. Which is important. Let's move on to my next question, and that's basically around the same topic in a sense that some printers are fitted with dispensers inside them to do top-up, as it were, or corrections, for missing paste, misprints, things that are picked up by the SPI system. Is it better to have that dispenser built into the printer, or is it better to have it as a standalone unit following the print process?
I would start. We do have this possibility to build in dispensing systems in our printers, but they are not made to do a rework within the printer. They are made for an add-on process, because if you have difficult products and you have an area with a lot of demand for paste, then you can really add paste on this pad and using a normal stencil print the other sides, or you have some add-on for glue and to fix one of the tall components or a heavy component. It's not made for adding little pieces of paste where you have, like, say, 50% of the pad of the depot missing,
Right.
because that is actually very, very difficult. And the feedback, you never know what's coming, and how you would do a feedback with an SPI, which is the next step, and you had to do this repair work before. So this would, in my
so
opinion,
you're
not
using
work.
it really to avoid using step stencils and things like that?
Yeah, in
Where
some
you-
cases you can do this, and honestly, it makes no sense in the printer, within the printer, to do like 100 or 200 apertures, you know, to dispense this.
Yeah.
It's too time consuming. But one or the other, and it's very, very much requested by EMS companies.
Yeah. Okay.
I agree. I'd also like to say, though, that we want to put the right amount of paste in the right area, in the right time, and with the closed-loop tools that we have nowadays, I think that we should be getting the perfect print out of our printers. We have the accuracy that the printers now have compared with years ago, but also really the advancement in the closed-loop systems, in the data that we're collecting, in the feedback, the ability, who knew years ago that we would be changing paste pressures, paste speeds, print speeds, separation speeds, actually during production, that different changes in batches where you can get different stretches, etc. And now the feedback is that quick from the SPI. I would hope for the future that we wouldn't be using any correction tools in that respect.
You should be able to get it right first time.
It does affect
Okay.
throughput. It goes against a lot of what our customers want. Let's just get it right.
Right. Okay. Would you agree with that, Harold?
I absolutely agree, but we are the company with 100% 3D inspection right into the printer, and one aim behind that for sure is that a rework inside of the printer is the best rework. In my case, if paste is missing, we simply reprint. And if we check inside of the printer, the quality of the print, you simply bring up again the PCB to the stencil, print it again, check for bridges, and you are done. And with the dispensing technology that we also have inside of the printer, jet or needle dispensing, typically we are way too big for the tiny apertures that are typically critical. If we are talking of micro BGAs or similar components, then a needle or a jet dot that we can perform there is way too big for the volume that we are needing there.
But if you're adding top-up dispensing and full AOI inside a printer, is that not going to slow down the print cycles?
For sure. We are needing the inspection time right inside of the printer, and so it's typically for productions where the pick and place is taking more time than the printing time. So for standard board with double euro size, we are needing something around 30 seconds. And for sure, you have to have the time for that. If you have very fast pick-and-place machines and you're aiming for 20 seconds, then you will have two different machines for inspection and for printing. But if you have a high-quality, tiny production with less demand on cycle time, then it's a good option to have the inspection right into the printer. Yeah.
Right, okay. So I think you've already answered this one, Torsten, but what features do printers need to deal with step stencils effectively?
In our opinion, that's quite clear. We need to have a fixed alignment in between the stencil position and the squeegee position, because if you have, let's say, a normal step stencil just with a tiny step up or step down, that's easy. But if you have a huge step up or a wider step down, then you probably need a special squeegee plate which is cut, and therefore you need this orientation which keeps the same. Otherwise, these fingers on your squeegee plate cannot really follow the step down or the step up, and in that case, you are not as repeating with printing, especially in this area, would have misprints or you will have overprints in that area. So you need to have this done. And the advantage of a pneumatic head, what we still use in our serial machines, is that we can follow even huge step-ups easily, because this is more like a suspension system. I always compare this with a luxury car, you know. They're always nice with their suspension systems, and that's what we like to do the same in our machine. And that's the requirement for step stencils.
Excellent. Rick?
I agree entirely, and having, so main points there, the deeper, so we have the compliant squeegee head with very fast closed loop feedback, but equally important is for those deeper, the deeper steps, as Torsten said, having the slits in the squeegee so the squeegee can then go into those and clean them out. But it'll be interesting the way the industry goes for the future, and whether we see two printers in a line as well, because as we need to get more and more functionality on the PCBs and the real estate gets less and less, we do have the issue with the keep out zones on the step stencils as well. And I wonder whether for the future there will be some investment perhaps in two printers, so basically with one stroke you're doing the more coarser pitch, and then the second stroke the more finer pitch, and then you've got your stencil routed out to cater for that first print stroke.
Do you think it might go back to the old days where you might have one printer being a stencil printer and the other one being a mesh-based printer to do the hybrid stuff?
I think there will be some changes in the future, certainly in technology, to accommodate this.
Okay, interesting. So it's in an increasingly sustainable world. Are paper cleaning rolls acceptable? And if not, what are the alternatives?
We let you start because you could not say anything to the last topic.
Yeah, for the cleaning paper, I think in my eyes, the cleaning process in the printer is one of the most critical processes, and it's very rarely checked by the customers. So it's very important on our side to teach the customers how to use a stencil inspection, for example, or at least to verify if the cleaning system is still working as it should. So, for example, we show in our trainings, in our in-house trainings, the customers a transparent stencil where you print on the bottom side and then verify that the cleaning system is really working excellent there, and that all the relative movements are working as they should. Because usually you just see the stencil during the cleaning and you don't know if it's really clean on the bottom side, and nobody checks. But that's absolutely important for the printing quality. If you have solder spheres on the bottom side, with fine pitches and thin stencils, you can have easily 50% or even 100% more volume there just due to a solder sphere on the bottom side. Right. And that's something I think we really have to push our customers to be aware of that. And coming back to your question, sorry for the excurse. The cleaning paper, I think, is absolutely important. Also, the quality of the cleaning paper. It has to be lint-free. It has to be stable enough to have a good cleaning process there. We need enough room to have room to get the solder spheres away from the stencil into the paper. It has to fit to the solvents that we are using there. So the cleaning process, you recognize it's really one of my core topics in the training to make the customers aware that the cleaning is really very important for high quality.
Is there such a thing as a completely lint-free cleaning roll?
As much as possible. For sure, it depends also on the stencil quality. If you have some sharp edges on the stencil, maybe some leftovers from the laser process, special designs, then you might also generate lints during the cleaning process, and that's an absolutely no-go. And therefore, you get a good, or you need a good contact to a stencil manufacturer that's taking care about rounded corners, no sharp edges, maybe polishing processes. So there's a lot to do about cleaning. It's surely not the core topic for printing, but very, very important.
All right. Okay. Well, we're starting to run out of time, guys. So I want to jump to my last question. Sorry, do you want something specific?
I think we both like to add something.
Okay, all right.
First of all, I make it short.
Important?
First of all, yes, paper is very important because this also is like a safety thing in between, metal and stuff, and it does not or it prevents the machine for scratching
Yeah.
the stencil. And a good cleaning system, you can program as you want it, with vacuum, oscillating, not oscillating, fast, dry, whatever you need. So you can also react to special stencils, to special requirements. But the paper, lint-free paper, is needed, in my opinion.
Yeah. Okay. Excellent.
And just finally, and I'll keep it succinct, I want to move away from paper.
Yeah.
I really do. It's unacceptable that we're filling up lots of landfill. Our industry is not exactly full of early adopters. And we are looking at a lot of research into what we can do to move away from paper. But at the moment, I think as has come across, we can just make cleaning more efficient, more poker yoke, and use as less paper to give a consistent clean as is possible. So at least we start decreasing the amount of landfill of this hazardous material.
Right. Excellent. Excellent. Okay. Well, gentlemen, I think we're pretty much out on time. Oh no, we've got a couple of minutes. We can go to our last question here, and that is: should modern printing systems monitor factory ambient temperature and humidity, and should paste suppliers provide guidelines on how that may affect the paste performance?
Yes.
Yes. Okay, that's a good night.
That's what we do since years. Monitoring temperature, humidity, have limits there for not allow the machine to work. And also you get guidelines from paste manufacturers, what is the best temperature to be processed on.
But you really need to have also the monitors on the systems, on the printer systems as well, to do the temperature and the humidity, because it varies from site to site, even if you're doing the same print process.
We do have temperature control systems on the machine because they are also price efficient and they are very good in the efficiency, in the overall efficiency for the customer. But if you're really going into working with the humidity, then it gets financial-wise quite nasty. It's technically absolutely not a problem, but we always have to think in such case, what's about the rest of the facility if we really need to control only on this little spot of a printer, humidity and temperature? What about the rest?
Well, that's true. I mean, a printer could be sitting under an air duct or something, and it behaves differently, you know. Okay. Any views on that, Rick?
Agree, and certainly as miniaturization kicks in, and we did talk about 0201s, which years ago would be classed as advanced packaging. Environmental control's important, but not just in the printer. It's all very well. We don't have paste slumping in the printer, and then it sits there on a conveyor that's open to the elements. It slumps, and dust in certain cases gets in.
Yeah.
So.
Yeah. Excellent. Last word to you, Harold.
I absolutely agree. So temperature control is something that we are doing for centuries, I would say, because it's really important. As we also saw during the setup and when we printed the first boards, when the heating was still off here, it's absolutely critical for micro BGAs or 0105 or whatever. Yeah? So all the tiny openings really making trouble there. But as Rick also said, dust in my eyes is becoming more and more important. Temperature is easy to control. More and more customers have a complete environmental control for the production area, which is quite normal nowadays. And lucky us, that's really helping a lot. But I think dust for the finer apertures and sizes which are coming there is becoming one of the next big topics in there.
Great. Well, I want to thank you, gentlemen, for a great debate today. A very well debated topic. Thank you very much to Torsten Wegelin from ASIS.
Thank you, a pleasure to be here. Thank you.
Thank you. To Harold Groom from Kurzessa.
It was a pleasure to be here. Thank you.
And of course to Rick Goldsmith from ASM Assembly Systems.
Many thanks, Trevor. Many thanks, guys.
All right, and thank you to our audience for watching. Coming up in a few moments, after the break, we'll be going on to our next panel discussion on manufacturing for harsh environments. Hello, good morning, and welcome to today's panel discussion, Manufacturing for Harsh Environments. Whether it's increased electrification of automobiles, the increasing traffic heading into outer space, or explorers drilling deeper into the ground, the window for thermal extremities is widening and bringing increasing challenges for manufacturers. This panel is going to discuss materials and processes to help address these challenges. And I'm delighted to be joined by, to my extreme right, Corné Hoppenbrouwers from McDermott Alpha.
Thank you for
Hello, welcome.
the invitation.
To his left, we have David Greenman from Humisil.
Thank you for the invite.
Yep. And of course, to my extreme right here, my right, I have Karthik Vijay from Indium Corporation. Karthik. Yeah. And then to my left, I have Jennifer Fijikalski from AIM Corporation.
Happy to be here.
Okay, thank you. So that's our panel today. Let's get started. Our first question is, in addition to those mentioned in the intro, what other applications are classified as harsh environments? And we'll
If I can
with you,
start,
Gordon.
yes. Harsh environment is for everybody different. If you are in electronics, soldering materials, you're looking at the harsh environment at a different way than like my colleague is looking at the point of coating. And the basic with harsh for the electronic, for the soldering materials, is that you make a bond, an intermetallic, and this bond will grow by time and temperature. And that is the harsh condition.
Right.
But for conformal coating, probably it will be totally different, right?
Absolutely. What we're seeing with the increased packing density of components, the fine line technology, conformal coatings are now becoming a must-have rather than a nice-to-have. And with the boards going into ever more harsh environments, into electronic vehicles, into everyday electronics, white goods, etc., we're seeing an increase.
Right, okay. And would you agree with that, Jennifer? Have you any other sort of applications that you think would fall into the realm of harsh environments?
Yeah, I think oftentimes when you think of harsh environments, you think of, military, aerospace, but think about your phone and how often you drop that, or how hot it gets on a hot day. So it's not just about like where you're taking these devices and who's using it, but what demand you want from those devices. So I think it goes beyond automotive, beyond military, but consumer electronics are the next generation of high reliability products that we want to be focusing on.
Okay. Karthik?
Yeah, I'd broadly echo all those comments. And I think Jennifer hit it because in the past, the definition of harsh was, deep down drills, drilling applications, or life-critical applications. That's no longer harsh. We see that merging in automotive, communication, industrial, in their separate spaces as well as the convergence, because all of that is happening in a vehicle or when you're moving, and then your consumer devices as well.
Yeah.
So.
Okay, so obviously the definition of harsh is expanded. Current automotive requirements are testing up to 150 degree Celsius or down to minus 40. How can, are there other applications that expand the extremities even further than that? Back to Corey.
It's nice that you bring it up, because most of those harsh environments are closer by than you would think. Everybody think about under the hood of a car. But if you look to LED, right? If the junction temperature of the LED is 150 degrees, that 150 degrees go to the lead frame in your solder joint, right? And further on, that cools down on the board. So the solder joint on the LED side will fail within the life expectancy of the LED. And it is so close by, and you will not see it or notice it.
Yeah, it's a really interesting example there because, they typically market LEDs as having a lifetime of, 150,000 hours or something.
Forget it.
But the electronics only last 25,000 hours.
Yeah,
So it's
it will not.
ridiculous.
It will not.
Yeah.
No.
Yeah. Okay.
Yep.
David?
Certainly from the conformal coating side, we are developing products now to exceed 150 degrees Celsius. As you say, the thermal shock is one thing, and we've been developing coatings. And we're also looking at the effects of putting the coating over no clean, over vitrified flux. And with the increased packing density I mentioned earlier, we're seeing a lot of problems with coating over that flux. We're seeing cracks and fissures. And in fact, my colleague, Mr. Brightwell, presented a paper at SMT recently on that in conjunction with Zestron. And it was a very interesting development they've
Yeah,
done.
flux chemistry is one of these things that keeps changing a lot. You know, I mean, are there certain activators within the fluxes that are causing this issue?
Yes, it's the flux will vitrify. We may have underneath the flux non-reacted activators that can, once you put a coating in, the coating not only keeps problems out, it traps problems in. And so underneath that, you can get dendrites growing, you can reduce your SIR, you can get intermittent faults happening, all of these things.
Right.
So it's what we're seeing is an increase in industry looking at cleaning in one way or another.
Okay, Karthik?
A couple of additional points. One is it's not only the effect of increased operating temperatures or service temperatures, that combined with increased thermal cycles. So as an example, minus 40 plus 110, which we would think relatively mild, or 125 degrees C for 1,000 cycles, now needs to be qualified up to 3,300 cycles. So your emission profile completely changes. And then you got hotspots in this profile where you got power DPACs or power QFNs, where you got hotspots at 150 or beyond. So that's one aspect. And to Dave's point about the flux residues, you've got increased thermal cycles, but you've got enhanced SIR requirements as well. I'm talking the prism of electrification in e-mobility. So if you look at standard IPC SIR, which was thrown out by automotive, for the last 3 years, because it's just not good enough to withstand their conditions. So a 7-day or 168 hours is no longer good enough. 5 volts is not good enough. 0.5 millimeter pitch is not good enough. 100 megohms is a minimum SIR threshold is not good enough. So instead they're migrating to 1,000 hours, 0.2 millimeter spacing, 50 volts, and minimum thresholds of 500 megohms with a B52 or a B53 test vehicle. And this just for the flux. Now throw in your accessory materials like conformal coatings and underfills and all of that. Again, all the rules of the game change.
No, I mean, it's an excellent point, Sen, and it's actually one of the problems is that the technology is evolving at such a rate that the standards obviously are taking quite struggling to keep up with it. But you're absolutely right, and that causes issues. You got anything to add to this, Jennifer? Or yeah? Okay.
Yes, I believe beyond thermal cycling, and I think miniaturization is a big part of it also. So you want to be sending the same amount of power through a smaller space. It's going to get hotter and hotter due to resistance. So as these devices are getting smaller and they're hidden in the device it's actually going to be used in, you need for the reliability to be maintained as it's getting smaller and smaller.
Right. Okay, good point. We'll stick with you and let you go first this time because to try and make it better. The first question is how can manufacturers mitigate vibration in assemblies?
In assemblies?
Yes.
Well, some of that can come down to the way you set up the assembly line. So just having, vibration-proof floors and such like that. Going on the ground floor as opposed to the fourth floor, simple things like that. And I think it's, again, challenging as devices and components are becoming miniaturized because any small movement can make it so that the component is off of the PCB. So I think it's just paying attention to the small things.
Yeah. No, it's a good point because, in Asia, of course, there's a lot of factories that are up on the 3rd and 4th floor. So vibration can be an issue that causes, reliability issues.
I look at your question in the context of the reliability of the assembly. So again, to put it in an automotive prism, the time to market for these products are shortening big time from, let's say, 3 years to 12 to 18 months. So your DV/PV has got to be spot on. Also, your cost of ownership and striking the right balance between reliability versus meaningful reliability versus the cost And there, it's, a lot of the design variables come into play. So having realistic expectations, but also, how do you damp it? What accessory materials to use? As an example, with CTE mismatch, what kind of TGs are you using on your FR4 boards? All of these factors are being looked at a lot more carefully than in the past. So.
Yeah, okay, from the solder point
Either
of view,
one.
right?
Okay.
On vibration, let me start to say, solder is to make an electrical and terminal connection, and you should never put a mechanical load on it. Now, in case of vibration, you put force on it, and to prevent that or to reduce that, you can use underfills and glob tops, and also in how do you call that? Not coatings, but potting materials, to minimize or to damp those vibrations. But it's still a concern if electronics goes more closer to you, like in elevators, sorry, and cars and stuff like that. It comes closer to you and becomes more a concern.
Right.
Certainly, from our point of view, we look at it on the finished product.
Yeah.
Applying a conformal coating will help dampen some of those vibrations. It also, we have developed some support compounds, some gels that are being used in the automotive industry on high power boards for electronic vehicles, supporting large electrically type capacitors. And it's, vibration is something we now test for. You were saying the test methods are changing.
Yeah.
We've got to change. We've got to go with the industry, and we've got to run with it.
Are there IPC standards on vibration? That is it covered in any way?
Not on any of the standards that are in current existence.
Interesting.
I think what makes vibration testing so difficult is you can have a standard test, but it depends on what the actual demand for the device is. So, you can have a standard test, but how is it actually going to perform, when it's being used?
Right.
It's unique to the device, the customer, such like that.
A lot of times testing the board in isolation may be meaningless when you integrate it with the subsystems and test it at a module level. So that's why I said the design variables, all of them have to be taken into consideration.
But
It's certainly becoming a much bigger issue with EV, coming on the scene. So, it's something we're going to have to be aware of going forward. You wanted to say something, David?
yes, I was just going to say that what we're seeing is the industry is now starting to put out its own specifications, its own test methods to cover the ones that are missing from the international standards as well as the IPC standards, etc.
Yeah, that's a good point. Okay, Jennifer, back to you. What specialist solders are needed to operate in harsh environments?
Something that has high mechanical strength is in huge demand for any high reliability application. You want it to, not crack. You want it to have high thermal cycling abilities. Something that's going to last a long time and still have the ability to perform in human environments and not have the residues that where dendrites will grow and where intermetallics will ruin your device. So I think at least at AIM-Starter, we're focusing on developing more high reliability alloys that aren't just your traditional SAC 305. So it's about having a strong research and development team that will try new things.
That's a good point. I mean, do you think, Karthik, there's more work needed done on the alloy side for more reliable solders for harsh environments?
Absolutely, it demands it, because we talked about the trends of increased thermal cycles and or increased operating temperatures. So SAC's losing steam, we know that. But if you look at it in the context of PCB assembly versus power modules, typically when you need an alloy that's more reliable, you want it to be harder than SAC. But something that's too hard will not give. So you want that ductility as a sponge, but you want that right balance. If it's too soft, it's going to tear. Another constraint of PCB assembly is the melt point.
Yes.
Versus power modules, you don't necessarily have that constraint. You could go, even hotter. So balancing all of these variables is key for, to establish like -40 plus 125 C for 3,300 cycles and pushing the boundary to 6,000 cycles, just as an example. So.
Yeah, on the alloys, the solders, right? I think we all know that there are particular alloys like Inalot and so on that are available. But most of the time we are sometimes surprised that customers take, for instance, stencil thickness closer to the smaller component, to very small. But those components are the ones that fail last. They are the bigger ones. To the big gap between the two pads, you get forced by thermal expansion differences. And the thinner stencils are worse for the big component because you ended up with too less solder, less intermetallic area, and there it fails. So it goes far more behind than just choosing a right alloy or put in a good potting materials. It's a combination of.
Right, yeah.
And to add to that, I think it's necessary for the various suppliers to work together to qualify a combination. Often we find that one flux, one solder paste will work well, another one will work bad. So it's necessary to do your process validation, basically.
Right, right.
I mean, just to play devil's advocate there, we see in some cases that people think, okay, regardless of the situation, only a higher rel alloy is going to do the job. And there's got to be some caution there because outside certain process downsides like increased voiding, which typically these high rel alloys are more prone to, a very hard alloy might actually be counterproductive. So to Courtney and Dave's point about the design variables, it's important, what kind of PCB material sets and what component sets, what kind of CTE mismatches are you really seeing, and then make the call.
Yep.
I mean, that is an excellent point because, I mean, in the semiconductor industry now, I mean, one of the big things that's happening is heterogeneous integration, where you're making sure all the materials involved in the package are compatible and there's few CTE mismatches. I mean, but surely should we not be having that further up the stream at the assembly side as well?
Well, I think you made a really good point speaking on compatibility, because I think, we're talking about optimizing your process and doing it all right the first time, but I think something that's often overlooked is rework, because you need your rework alloy to be compatible with your initial alloy, and that needs to be reliable in the long term as well.
Yeah.
That's an interesting point as well, Jennifer, because I mean, a lot of these BGAs, I've got SAC 305 balls on the bottom of them, and you're using different mixed alloys basically on the board, and as I say, that you should be using the same material to rework it at the same time. Let's move on to the next question. Are conductive adhesives structurally more capable of handling high temperature excursions than solder? Now, we've got 3 solder companies on this panel, so I'm pretty sure the answer is going to be no, but let's put it out there.
Okay, the answer is no. you give that in as an open goal for that. All those things we discussing today, right, it ended up all together as a package where we can cooperate with a harsh environment. Once you define what is a harsh environment, it could be high moisture, it could be high temperature, it could be high vibration, and it depends where you're aiming for to improve your product performance.
Right. Okay.
Well, conductive adhesives have got its space. Again, it's a question of cost versus performance. Soldering is a known process, lower cost of ownership. If it can do the job, why not? Versus in die attach applications where you've got conductive adhesives still being used that are silver filled for a specific reason. Again, depending upon the operating temperatures, if I take sintering, it's heavily loaded with silver. The cost per gram, as an example, could be 10 times the cost of solder, but it's still got its space. So it's extremely design dependent and end application requirements dependent.
No, I agree. I just wish you could find something alternative to silver for the conductivity in conductive adhesives. But do you have a view on this, Jennifer? Or?
I think I would agree with what everyone else has said today, in saying that I think that there's market for both. Right now, it's not one or the other, and I think that it's about exploring what works best for the user.
The application, yeah. Okay. Here's an easy one. and it's directed directly at you, Mr. Greenman. What type of conformal coating is best for harsh environments?
Sorry.
What types of conformal coating? Because you get different types. You get
Yeah,
acrylics,
yeah,
you get...
quite.
European,
Okay,
etc.
so basically with what we're doing now is we're looking at coatings, we're improving the flexibility, we're improving the electrical performance, and what we're finding is with high volume, and then it's nearly always UV cure. So we have now a range of UV cure products that can cater for every environment. And having said
Why is that? Is that because UV cure is faster
Yep.
than the temperature-based
faster,
and
it's
more
instant.
more reliable?
You get a secondary cure mechanism, so that if the coating is underneath in shaded areas, you get a secondary cure. And we have proven by SIR testing that as it gels underneath the component, it obtains good SIR values. Can measure it with the fully cured product. It never goes absolutely solid like the product on the bare boards or on the top of the boards. But that is, in a way, is good, because then you're not going to get a hard product underneath a component popping that component off.
Right.
So these are the areas we're looking at, and we're finding that we've recently launched a product called UV 500-2, which is a minus 40 to 150. We've done 3,000 cycles, no problems at all.
Yeah.
So
right.
that's the direction we're going in.
Right. Okay.
But just to come back, compatibility is important, and process validation is important.
Okay. Well, I think that's some good points you made, David. I think, does anybody have anything to add on coatings, or are you quite happy to move on to our next?
Yeah. No,
Yep.
we talked about alloys, we talked about chemistry, flux, and also compatibility with a coating. Because if you have the best coating and a good solder, if there is a conflict, then it doesn't work, right? It has to do a job, the coating, and functionality that you add to your product to give it a better performance in a harsh environment. That's the goal. The fluxes become more and more complex. We have low melting alloys where the activation package is totally different than alloys that have to work on a higher temperature. And that all has to be compatible with coatings and different type of coatings.
Yeah.
Hard, soft, silicons, acrylic, modified acrylic. And obvious customers don't want to clean. But if you clean and there is no conflict, it works the best, right?
Yeah.
But they don't want. In Europe, they don't want to clean. In the end, again, if you communicate with your coating supplier and your solder supplier, paste or flux, then there will be find a good solution.
Right. Right.
And I think one thing which must be considered before conformal coating is the surface energy of the board after full process. It has to be above 38 dyne centimeters to get a good adhesion and good wettability.
Right.
So it's important to check that.
Good point. Good point. Well, unfortunately, gentlemen and ladies, we're running out of time, so we're going to have to end our panel there. I want to thank them very much for a superb debate today. Corna Hopperbrouwers. Hopperbrouwers, I got it correct.
Thank you.
Sorry, from McDermott Alpha. David Greenman from Humasil.
Thank you, Trevor.
Karthik Vijay from Indium Corporation. And, of course, Jennifer Fijalkowski from AIM Corporation.
Thank you.
Okay. Thank you all for taking part today. And thank you to our audience for watching.